Okay, today we are going to continue with the literal equations that we talked about in class this week. So the first one that I want to go over is b plus the quantity, of c minus 2 times d equals 7. And we're trying to solve that for c. So what we talked about this week is when you're solving a literal equation, it's always going to give you an indicated variable to solve for. So in this one, for example, we're trying to solve for c. So we're trying to manipulate this equation to get c equals. So what you're going to do here, first, we have something outside parentheses. So just like equations, we're going to have to distribute here. So we have b plus c times d is cd, negative 2 times d is negative 2d, equals 7. What you're going to do next here is we're trying to move everything that is not c to the other side. So you can do this all in one step. You can break it down to 2 steps, which I'm going to do. The first step, I'm going to move b to the other side. It's currently being added, so you do the opposite, you subtract it. Now what we do next is we are trying to get c by itself, so we have to get rid of minus 2d. You do that by adding 2d. So now we have cd equals 7 minus b plus 2d. And your final step here, we're trying to solve for c. So how you get c by itself, this is multiplication. To undo that, you do division. So we're going to divide everything by d. So you can divide all 3 parts by d like this, or you could put it all over d. The only time that you'll see it kind of like I just did now is because that the d's cancel here. So then you'll see it like this, 7 over d minus b over d plus 2. But if you left the whole thing as c equals 7 minus b plus 2 all over d, that would also be correct. Okay, moving on to the next one here. Number 2, we have a equals c over d, in parentheses, divided by, in parentheses, e over f. So this one looks confusing at first because you have a fraction over another fraction. So what we can do here, we're still trying to get, I forgot to put what variable we're solving for. We are solving for c again. Sorry about that. To solve for c, we first have to get rid of this dividing. So if you think about it, the way that we get rid of division that was on the quiz from last week, you get rid of dividing by whatever it is, a number, a variable, by multiplying. So the first step we're going to do is we're going to multiply both sides by e over f. What happens when you do that, on the right, those cancel. E over f divided by e over f is just 1. And think about when you're multiplying here, this is like a over 1. So if you multiply straight across, e times a, generally when you multiply variables, you'll put them in alphabetical order. So e times a is ae, and f times 1 is just f. And now on the right side, we have c over d. And now we're really close to being done here. We're trying to solve for c, so we have to get rid of divided by d. To get rid of division, you multiply. Whatever you do to one side, you have to do to the other side. And that's like multiplying by d over 1. So our final answer is c equals, and if I put it in alphabetical order, it'd be ade over f. Okay, moving on to the next one here. we now have to solve for x, and our equation is a times the quantity of x plus b equals 6ax minus 9ab. And we're trying to solve for x. So first, just like the first one, we have this variable outside parentheses. So first thing we should be thinking is distribute, always. So we have ax plus ab. Now we're trying to solve for x, but what you notice is you have x's on both sides. So anytime that happens, we have to move it all to one side. So I'm going to choose to subtract 6ax from both sides. You could have also subtracted 1ax from both sides and got the left side to cancel. So if we have 1ax minus 6ax, that's negative 5ax. We still have our ab. 6ax minus 6ax cancels, and we have negative 9ab. Now we're trying to get x by itself because we're trying to solve for x. So we have to move the ab to the other side. It's currently being added, so we need to subtract it. So on the left side, we now have negative 5ax equals negative 9ab plus negative 1ab makes negative 10ab. And we're really close. We want to solve for x. This is all multiplication. You undo multiplication with division. So if we divide both sides by negative 5a, we are left with x equals negative 10 divided by negative 5 is 2. A divided by a cancels, so we just have 2b. So x equals 2b. Moving on to our next one here, number 4. We have p equals 2a plus b plus c over 4. And we are trying to solve for b. So how you do this one right here, we have to get rid of this whole thing divided by 4 first. You undo division by multiplying both sides by 4. So on the left side, 4 times p is 4p. Make sure you don't distribute this 4 because the 4 divided by 4 just makes 1, it cancels. You shouldn't be distributing when it cancels out. So we have 2a plus b plus c. And now you could do this in two steps or one step if you want to subtract two things at once. Just to make it easier, I'll do it in 2 steps. So I'm trying to solve for b. So first I want to get rid of this plus 2a. I get rid of that by subtracting. So on the left side, I have 4p minus 2a. They're not like terms, so I have to leave them separated. And now if I'm trying to get b by itself, I'm going to subtract c from both sides. So on the left, I now have 4p minus 2a minus c. It doesn't really matter the order, and that's equal to b. My goal was to solve for b, so I have b equals. Okay, moving on to the next one here. Number 5, we have negative 6x plus 2y equals 10. And we are trying to solve for y. So this is similar to one we did in class. If you're trying to get this by itself, you have to get rid of the minus 6x first. We do that by adding 6x to both sides. So now you have 2y. You could either put 10 plus 6x or 6x plus 10. I'm going to put 6x plus 10 because once we start dealing with linear equations and graphing, you're going to want to put it in this form. And final step to get y by itself, you undo multiplication by division. I'm going to divide every part by 2. You could have put it all over 2, but if you divide each part, this is going to really help once we get to graphing linear equations. So if we do 6 divided by 2, that's 3x, and 10 divided by 2 is 5. So you have y equals 3x plus 5, and that's something we call slope-intercept form, which we'll get to next unit. And now our last problem today is m equals 7 minus 3 times the quantity of p minus m. Step 1. Whoops, sorry, I keep forgetting this. And you're solving for p. Step 1, we have some distributive property going on here. So -3 needs to be distributed. So we have m equals 7 minus 3p. Negative times a negative would be a positive 3m. And if we're trying to solve for p, we need to start moving everything that's not this to the other side. So you get rid of plus 7 by subtracting 7. So m minus 7 on the left. And then on the right, we're trying to solve for p, so we need to get rid of this. It's being added, so we subtract. So on the right side, notice we have some like terms. 1m minus 3m. So 1m minus 3m would be negative 2m. And now we're really close. To get rid of the negative 3 times p, you divide. And just to keep it consistent, we'll divide each part by negative 3. So our final answer, negative divided by a negative is a positive 2/3 m. And negative divided by a negative is positive 7/3, and that equals p. We already solved for what we wanted. There's no clearing fractions now because we already did what we were trying to do. We were trying to get p equals.